completely curved waves, would the experiment work if it was, for example, in an hexagonal shape? We would also like to see a different kind of experimentation because part of the problem was how it affected the visibility. However, it did not specify what visibility. So, did you did you investigate how it would it affect on visibility under, for example, a thermal uh, I don't know, a thermal camera, for example, or like an ultraviolet light or a thermal, no, infrared light. Or also maybe if those on a different medium, for example, instead of being on air was underwater, what would happen? How would it variate the perception? We would like to know, well, you mentioned that the experiment worked under certain distances. If it was too close, it didn't. If it was too far, it didn't. But you didn't specify what was the difference. Is the experiment like not working on the same way, or is the perception different if you're too far or too close? Because you said it didn't work, but you didn't explain exactly how. Um, well, we would actually also like to say that you missed pictures of what you said because you said that you tried with cameras, but you didn't actually show it. Besides, considering that the camera has a different perception from the human eye, and well, and another thing that is kind of an extra, but we would like to see it on the project is, can you create a specific image besides creating invisibility with set lens? And I think that would be it.
Okay, thank you very much. Let's proceed to the discussion part.
To the begin or something, or maybe you have some questions.
Well, yes. First of all, I would like to, like, if you try to see how would it change if the lens, besides having the ripples, if it was convex or concave, how would the impact of the light change the phenomenon?
Okay, should I share my screen again? Maybe just can you watch it?
Yeah, we can watch it now.
So you said what was the question? Maybe if the instead of having a cross spherical and the rear surface, if we had what?
Can you repeat it, please?
I tried to remember what the question was.
Oh, yeah.
If you
Well,
could say it again.
yeah, you're showing a lens that is completely plain. I'm asking if you could explain what happened if the lens had a concave shape, for example.
You
If
mean
focusing on the lens different.
for the rear surface, like this one
Yes.
right here, right? Yeah.
Mm.
We didn't investigate that because the definition of a lenticular lens says that that is how they basically look like, and maybe changing its rear surface would have uh, way two different outcomes, and maybe we would not even talk about invisibility in this case, and that is not generally what the definition of the lenticular lens is, so
But
that's why we didn't change it.
a lenticular lens is not necessarily plain and have different shapes as long as there are many lenses combined to to create a different effect. So it could be concave and it could be convex, and I think it should be included because the question was, how would changing the shape of the lens affect the phenomenon? But
Yeah, but our references generally mentioned a shape like this, so we prefer to, instead of change the rear surface or the uh, front surface, generally change the other properties of the geometry of the other geometry properties of the lenses.
Okay, I still don't think that answers my questions, but still we can go to another one if you prefer.
Okay.
Another, well, part of what I mentioned on the resume of what I wanted to say is the problem mentions visibility, but it doesn't mention visibility to the human eye, so it can use different types of perceptions.
Okay.
So, did
Okay.
you investigate how does it affect, for example, under a thermal vision, if the phenomenon
Well,
works the same or has a different effect?
a thermal vision or generally any other kind, well, it is almost the same because what we did to measure visibility was to measure the cantelas of light, which is basically intensity of light. It doesn't have to do much with the wavelength or another property. So uh, what we did is to measure about how much light there was, not what kind of light. So um, there is no problem with that. Visibility doesn't talk about the different colors of wavelengths.
Okay, well, now that you mentioned the intensity of light, could you explain me how it affects, for example, if there's a limit of brightness or of darkness necessary for the phenomenon to work?
Well, when we have much bigger value for intensity, that it means that there's way too much light coming to your eye or maybe your camera, so it is way brighter. It will have too little candelas of light, then the object seems invisible.
Okay, but you don't have a parameter. Uh,
Uh, what do you mean? I don't have a parameter.
yes, a limit of the brightness, for example, or of the darkness. Like you can only say like with the eye perception.
Well, in order to measure the visibility effect, we do not really need a limit. We just need to see what the relation is from the intensity measured without the lens and the intensity measured with the lens. That's what we need. There doesn't really have to be any limit.
Okay. Does the lens needs to have an specified size, or well, if it doesn't, could you explain like easily the relationship between the quantity of ripples it needs on certain size?
Well, you mean how many lenticules per meter we used? Like
Yeah.
uh yeah, okay, that is basically the picture width of each lenticular lens. It is this parameter, and it is something that we kept stable in our experiment. And this basically changes the r angle, so it is an important parameter. But I don't know whether I really answered your question. Did I? What was the question at the beginning?
Yeah, the answer is okay. We can move on to the next one. Well,
Okay.
did you maybe try on different mediums? How does the phenomenon work, for example, underwater?
Oh, okay. So you mean like not the air or something else? Well, if we change medium, as long as the weight as the n, the refractive index, but not for the lens. Now we're talking about the medium. As long as it stays stable, the effect is basically the same. And yeah, that's it. So we do not really need to change the medium because if it is the same in every position, the effect is the same.
Okay. And well, lastly, the an extra application. Do you think there's a way that besides invisibilating an object, could you project an image with the lens?
Oh, like create a different image. Well, that could be uh, the case under some other conditions, but that's not what the problem really states. So we did not mess with such a case.
Okay.